Hey everybody, it's Ms. Dupree. In today's lesson, we're going to explore mixtures. You've already learned about elements and compounds. And in our world, a material or substance can be one of three things. It can be an element, like gold, or it can be a compound, like water, which we've learned is H2O, or it can be a mixture. Today, we'll look at some of the characteristics of mixtures that make them different from elements and compounds. Let's start by just defining mixture. A mixture is made when two or more substances are combined. Sounds pretty simple, right? Except wait, isn't a compound made of two or more elements combined? What makes a mixture different from an element or a compound? Well, there are some characteristics of mixtures that make them different. Let's take a look. First, when elements combine to form compounds, we learn that they chemically bond together. And when this chemical bond occurs, it creates an entirely new substance that has properties that are different from the original elements. So remember our example, we had the flammable element sodium and the poisonous element chlorine, but when they chemically combine or bond together, they form completely safe salt. Salt is a substance that has completely different properties from sodium or chlorine. But mixtures are different. If I combine water and sugar, there's no chemical bond happening. And that means that there is no new substance being created. I mean, yeah, we call it sugar water, but it's still just sugar and it's still just water. The sugar remains sugar and the water remains water. So in a mixture, the substances that are being mixed together, because they're not bonded, they're not making anything new, so they keep their original properties. Make sense? Another way that mixtures differ from elements and compounds is that elements and compounds are pure and mixtures are not. A pure substance is something that is 100% completely the same throughout the entire substance. For example, gold is pure because it's made of gold atoms and only gold atoms. Water, which is a compound, is pure because a drop of water is made of trillions and trillions of water molecules, which are H2O, and they're all identical, exactly the same. But a mixture is not pure. Remember that the parts of the mixture are not bonded together. So this means that in our sugar water, we could still separate the sugar and have sugar molecules which are different from the water molecules. So we have two different types of molecules in this mixture, which means that the mixture is not pure. So elements and compounds are pure, but mixtures are not. One final way that mixtures are different from elements and compounds is that they can be easily separated physically. Elements can't really be separated at all, because remember, atoms are the smallest unit that you can have and still have matter. And compounds are pretty difficult to separate. They can only be separated if you can break apart those chemical bonds, and that's not easy. So we'll be learning more about that in our next unit. But for mixtures, you need to remember that a mixture can always be separated as long as you have the right tool. And we'll look at the tools used to separate mixtures in a few minutes. Okay, so you should be able to describe how mixtures are different from elements and compounds. Now I want to take a look at some different basic types of mixtures. A mixture can be classified as heterogeneous or homogeneous. The root word hetero means other or different. So a heterogeneous mixture is not going to be the same throughout. A good example of a heterogeneous mixture is chocolate chip cookie dough. When you mix all of the different ingredients together, no matter how carefully and how well you mix them, you will still have maybe one spoonful that might have a few more chocolate chips, or one spoonful that has a little more sugar. So it's not the same all the way throughout. Other examples of heterogeneous mixtures could be a salad, cereal and milk, pizza, or soil. Heterogeneous mixtures can also be mixed together from different states of matter. They can be a mixture of solids or liquids or gases. So for example, our cereal and milk is a heterogeneous mixture made of a solid and a liquid. The root word homo means same. A homogeneous mixture is a mixture where the components being mixed together are uniform, which means that they're spread evenly throughout the entire mixture. An example is the air we breathe. Air has several different gases in it, including nitrogen, oxygen, and carbon dioxide, but these gases are evenly distributed throughout our atmosphere. So we're always going to have about 78% nitrogen, about 21% oxygen, and less than 1% carbon dioxide, and they're going to be evenly spread. Let's look at a special type of mixture called a solution. Okay, a solution is always going to be a homogeneous mixture, and it can either be a liquid or a solid. One example of a solution is that sugar and water mixture from earlier. When you mix sugar and water together, the sugar dissolves into the water, and makes it seem like it disappears. Now, some people think that this means that the sugar is melting into the water and turning into a liquid, but that's not true. Think about it. In order for something to melt, the temperature has to increase and get hot enough to melt it. But sugar dissolves in water no matter what the temperature is. So the sugar is not melting. The sugar is dissolving, and that means that the pieces of sugar are being broken down by the water into smaller and smaller pieces. The water's actually tearing the pieces apart. And they keep tearing them down and breaking them down until you end up with just the individual molecules of sugar, which are so small they can't be seen, and that's why it seems to be invisible. The sugar molecules, because this is a solution, they're going to spread out evenly into the water mixture so that everything is blended together. But remember, you still have water molecules and sugar molecules. They're just mixed together now. Solutions can also be solids. An example is steel, which is a metal that we use in construction. Steel is a solution made by mixing iron and carbon together, and they're going to blend together evenly, and then they're going to create steel. Liquid solutions, they're usually clear. When you dissolve the sugar in the water or salt in water, it seems like they disappear, and so they're clear. But solutions can have colors. Kool-Aid is an example of a colored solution because you've got dye in the Kool-Aid that turns the water red or purple or whatever color, but the powder and the sugar dissolve into the water, so it just looks like a clear liquid. Heterogeneous mixtures like the salad or the cereal and milk, they're usually much more difficult to see through, or you can't see through them at all. Okay, so now you should know the difference between a heterogeneous mixture and a homogeneous mixture. You should also know that homogeneous mixtures that are liquid or solid, we call them solutions. Homogeneous mixtures that are gases, like the example from earlier when we talked about air, if they're gases, they're still homogeneous mixtures. They're just not called solutions. We call them homogeneous mixtures. Okay, I said earlier that a mixture can always be separated. That's because the parts of the mixture did not chemically bond together, which makes the parts easy to separate back out. You just have to have the right tool. And this is actually really important, so I'm going to repeat it one more time. A mixture can always be separated as long as you have the right tool. That is one of the major characteristics of mixtures. So let's take a look at some tools used to separate mixtures. First tool is the easiest. It's just your hands. You've probably done this before, like when you've picked something out of food that you don't like. So my brother used to pick the tomatoes out of the salads that my mom made because he hates tomatoes. And one of my nephews will pick out every single teeny tiny mushroom if he sees them in the meal. So that's separating a mixture. Our hands are tools that we can use to easily separate a mixture. Now, to figure out what tool you need to use to separate a mixture, it helps to know the properties of the different parts of the mixture. So for example, we can mix iron filings and sand together. Shake that jar up and you'll end up with a mixture. Now, technically, you could separate them by just picking them apart one at a time with your hands because they do look different. But that would be really hard and it would take forever. But we know that iron is magnetic and sand is not. And so to separate a sand and iron mixture quickly, we could just use a magnet. So that's our second tool. A magnet is used to separate magnetic materials from non-magnetic materials. Our third tool is called a filter. And a filter helps to separate things that are different sizes. Filter is any tool that has holes in it. And so when you pour a mixture through the filter, the smaller pieces go through the filter holes and the larger particles get caught in the filter. And different filters have different size holes depending on what it is you're trying to separate. So for example, this colander is a filter and it's got pretty big holes. We use it for cooking. It can be used like when you cook spaghetti. You just pour the spaghetti and the water mixture into the colander and the water goes right through the holes, but the spaghetti stays on top. Coffee filters are another example, and they're made of paper that actually has really tiny holes in it. You can't really see them with your eyes, but if you look at a coffee filter with a hand lens or a microscope, you'll see the tiny little holes. So when you make coffee, you pour the coffee in the filter, and then you pour boiling water on top of it, and the boiling water goes through the filter, and it leaves the coffee grounds on top of the filter. Okay, our fourth tool is called distillation. Distillation is not actually a thing. It's not a piece of equipment. It is actually a process of boiling liquids to separate them. And this works because different liquids boil or turn into gas at different temperatures. So the example we have here in the picture is a liquid solution of ethanol, which is a type of alcohol, and water. Ethanol boils at 78 degrees Celsius, turns into a gas. But water has to be hotter to boil. It boils at 100 degrees Celsius. So if you had a mixture of ethanol and water, you could heat it to 78 degrees Celsius for a while. The ethanol is going to boil away and it's going to leave the water behind. Now, if you have a distillation tool, this is called a distiller. If you had this tool that could capture the steam when the ethanol boils and condenses it and takes it back into the jar on the other side, you can actually end up with both liquids in different jars. The water is going to stay over here and the ethanol is going to be over here. But if you don't have a distiller, you could just boil it long enough that all of the ethanol would be gone and you would just have the water left behind. Okay, our final tool is evaporation. And like distillation, evaporation is not a thing, but a process. In fact, evaporation and distillation both work with heat. So evaporation is a tool that we use to separate solutions where one part of the solution is liquid, like water, and the other part is a solid, like salt or sugar. So going back to our sugar and water solution, there are always students who think that you can just pour the solution into a paper filter and trap the sugar in the filter. But remember, in a solution, the sugar has been dissolved down into the individual molecules, which are so small they can't even be seen. So if you try to pour a sugar and water solution into a paper filter, both the water and the sugar are going to just pass right through the holes in the filter. But you can evaporate the water, either by boiling it or just by putting it into the sun. And the water is going to turn into gas and evaporate into the air, and it's going to leave the solid sugar behind. So remember that the tool that we use to separate solutions is evaporation. Okay, that's it for this lesson. Please make sure that you know everything on this review slide. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.